In this video you will learn how to build and simulate electric circuits with a simulation tool. You will learn how to create a simple circuit, a simple schematic consisting of voltage source and LED and a resistor. You will simulate the current flow inside the circuit. You will take measurements at interesting points in the circuit. And this video here compares 3 programs which are currently available on the market, which are iCircuit and MultiSim and TinkerCAD, and these are among the most popular currently available to you. And finally, as always, there's going to be a summary of the most important facts from the video at the end for you. So stay tuned in any case. And my name is Andreas from The Fearless Engineer, and here we go. Now, the first program we want to look at is called iCircuit. And let me briefly explain to you the layout of this program here. On the left, you have various options, menus for sources, for analog components, for silicon-based components, digital even, also some text labels and measuring devices, which you can find here. And the simple circuit we want to build here is the hello world of electronics. We want to power an LED using a current source, and we want to protect the LED from too much current. And in order to do so, let's click on sources. Let's click on DC source. This one here. Let's say we configure it to 9 volts. Now what we need, let's zoom into a little bit. Now what we need is a resistor. You can click on the resistor and then also change its orientation very easily. Then let's click on silicon and look for the light emitting diode. And as you can see, there are many other transistor types, NPN, PNP, MOSFET transistor, JFET transistors. We will look at all these types in later videos, but this is a broad range of transistor possibilities which you can integrate in your circuits. Also, you have operational amplifiers, which you can find here down below, both with and without rails. And the meaning of rails is also something which we will discuss later on when we get to operational amplifiers. But for now, we only want a simple light emitting diode, such as this one here. Okay, now before we connect these, let's look at the configuration of the entire background here. You can easily change the color from black to, let's say, white. Let's stick with white for just a second. You can adjust the grid to be fitted onto the background. You can change between international symbols and, for example, European, German symbols. This is the international version. This is typically used in the United States. This wiggly line for the resistor. Also, we can tell if we want to have the electric potential color-coded or not. Now everything is equally black. Now the electric potential is color-coded. Gray means 0 and green means highest potential. And we can switch on and off the values of the components. So that's the range of adjustments which you can make here. Now let's wire the components. Let's click on this wiring tool here and then simply drag and drop from one connector to the other. And as you can see here, as soon as I connect these to the power, to the positive terminal of the power source, all the components go green, which means that they are all on the same electric potential as the power source here. And since there is no backflow of electrons to the negative terminal, the potential does not change because no current actually flows. Currently, we have only potential and no current flow. In order to get a current flow, we need to connect the negative terminal of the battery to the minus connector of the LED, which is the horizontal line in this case at the tippy point of the triangle of the LED symbol. And if we connect it now, what you can see is a current flow going from left to right, and if we follow the path of current, we first traverse the resistor, and you can see the color actually change from bright green to a darker shade of green, going into gray. And as you can see, while we progress towards the negative terminal, you can see the color decrease even further, while on this perfect connector, the color does not change. It's gray from start to beginning because all connector lines in iCircuit and all other simulation programs, they have 0 resistance. They are perfect conductors. Potential changes only over components. And if we wanted to find out the amount of current flowing here, we could click on one of the connector lines and see that the current currently is at 7.22 milliamps, which is pretty low for an LED. Typically, LEDs should be powered by something like 25 milliamps, roughly. And in order to increase the current flow, we can simply decrease the amount of resistance here. For example, let's pick 250 ohms. And as you can now see, the current flow is somewhere around 28 milliamps, which is much more suitable to an actual LED in practice. We can also measure the voltage drop by clicking somewhere, for example, between resistor and LED, and we can see that the electric potential is at 1.87 volts. If we click here, the electric potential has gone down to 0 volts, and if we click in front of the resistor, it's at full 9 volts. So this measurement here is always the potential at a certain position. If we wanted to measure the voltage drop, we can simply pick this measuring device here, place it next to the LED, say, connect the measuring device to the LED, enlarge it a little bit, and we can see that the voltage drop across the LED is at 1.87 volts in this case. So there are some possibilities which we can use to simulate a simple circuit. This is done with iCircuit, and now let's move on to MultiSim, which is yet another possibility. MultiSim is provided by National Instruments. It's free of charge and it's available online. And if you register there free of charge with an email address, you can get such an account, as you can see here, and you can click on Create Circuit to get a blank canvas on which you can design your own circuit. There are some limitations to the amount of components which you can use here, but for small and mid-sized projects, this is perfectly fine here. Let's increase the resolution a little bit, zoom into this canvas, and then on the left side you can see the menu with the components. Let's also try to power an LED here, and first let's pick the power source. There's a large number of various sources available, and we are going to pick the DC voltage source, which corresponds to this idea of a 9-volt battery, let's say. Let's click on here. If you double click, you get this context menu on the right where you can enter for example, the voltage drop you want to generate. Also, you can change the symbol if you don't like this symbol here. Let's, for example, pick this symbol here, or what's typically used in Germany is this symbol here to denote a voltage source. Also, you have a marking of positive and negative terminal. So this is our voltage source. The next thing we want to integrate is the resistor, which is in this section of passive components. Let's pick the resistor as a symbol. Let's place it somewhere here. And as before, double-clicking gives you the parameters which you can now change. Let's say 250 ohms, as before, should be the resistance value of this resistor here. Next thing we need is the actual LED, which is to be found here in this section, in the diodes section. Let's pick the light emitting diode symbol, click it onto the canvas, and now we have our LED with a large range of parameters, far more than with iCircuit. We do not want to go into the details of this light emitting diode here. Let's just use it from scratch without making any changes. And the next thing we need to do is we need to connect all the connectors here in order to have a current flow. And in order to do so, we click on one outlet of the voltage source, drag drop to the inlet of the resistor until it starts to blink, and this red circle is going to close over the connector. Then let's click again, and we have the first connection. Let's do the same with all the other connectors. Second connection, and the last one is the third connection. And now the entire circuit has been closed properly, and we can now start to simulate it. And we do so by clicking on this triangle here. And if we want to know the amount of current flow through this circuit, we need to stop the simulation again, go back to the menu, pick one of these measuring devices here, for example, current flow, click it onto this line here, and then start the measurement again, and you can see that the current flow is at 33.018 milliamps, which is different from the current flow we saw with the iCircuit, which is due to the fact that the LED is configured in a slightly different manner, and this causes a different current flow. Now let's measure the voltage drop across the LED. In order to do so, we can use a voltmeter, which we place directly atop the LED, and if we now start to measure, we can see a value of 1.69 volts with a negative sign here, which totally differs from what we saw with iCircuit. And if we place a second measuring probe directly beneath the LED, we will see why this is the case. Let's place it right here, start again, and there you can see that the voltage drop now is not 0, but it's 2.4362 volts, which is somehow peculiar because we directly now connected to the negative terminal of the battery. So something seems to go wrong here. And if you look closely, here in the description it says that no ground node was found. A ground node pulls a certain position to a potential of 0 volts. And what we can do now is we can simply pull this entire connector line here to the negative terminal to 0 volts, and we can do so by simply connecting a ground node to this line like so. And now this has changed to 0 volts, and if we now start the simulation again, you can see that we now see a change in the voltage drop or the potential atop the first LED, that this is now set to 0, and now the voltage measurements we see are always related to this ground node here. And if we place a third measuring probe, let's say directly in front of the first resistor, like so, we can see that this is now at full 9 volts. So the majority of voltage drops across the resistor here, and after the resistor has been passed, a potential of 745 millivolts remains, which drop across the LED then. So that's an alternative to iCircuit, free of charge, available online, and the nice thing is that you can share these documents online with others very easily and in a straightforward manner. Let's look at a third alternative. Let's stop this one here and move on to TinkerCAD. TinkerCAD is provided by Autodesk, also free of charge. You can also register there with a free account, and then once you do so, you can click on 3D designs or circuits or code blocks or lessons. Let's choose circuits here and then create a new circuit. And the interesting thing about TinkerCAD is that it's very Arduino-centric, which is a small microcontroller. The Arduino, which can be very easily used in this simulator to build microcontroller circuits and to even code the Arduino using C++. Which is not what we want to do here. What we want to do is we want to build a very small circuit without the help of an Arduino. What we want to use is a 9-volt battery, like this one here. You can rotate it to the right, like so. And now what we need is a resistor. We can look for resistors here in the search field. Let's enter this resistor here, also rotate it by 90 degrees. And let's enter 250 ohms. Just as before. Now let's look for an LED, light emitting diode. Found one here. Let's place it here. Let's also rotate it a little bit. This connector here, actually this one here is the anode. This goes to the positive terminal. So maybe let's rotate it like this. So in this manner we can connect the positive terminal to the inlet of the resistor. Click here. Maybe click a second time somewhere in the middle to create such a 90-degree angle. Then we can connect the outlet of the resistor to the positive terminal to the anode of the LED. Also insert a 90-degree angle here, make it a little bit nicer looking. Then we connect the cathode to the negative terminal of the battery. And now the circuit basically is closed and we can start the actual simulation. As you can see here, the LED lights up. However, there is a warning which we might want to adhere to. It says that the current through the LED is currently at 27.3 milliamps, while the recommended maximum is only 20 milliamps. So this would reduce the lifetime of the LED. So we might want to increase the resistance value here, let's say by 300 to 350 ohms. If we do this, let's stop and start the simulation, you can see that now this warning has disappeared. So this is also a very easy and straightforward way to simulate simple circuits. And the number of components here is pretty extensive, especially around microcontrollers such as Arduino, but also others can be found here. And also there's a basic section with the most often used devices, components, basic, which you find in circuits: capacitors, potentiometers, push button, etc., etc. So this is a very easy way to simulate simple circuits. Now let's quickly summarize the most important takeaways from this video here. In this video, you learned how to build and simulate a simple circuit with a simulation software tool. You are now familiar with the 3 most common simulation programs on the market, which are iCircuit and MultiSim and TinkerCAD, and you can use them to build and simulate circuits of small and also medium complexity. And the big advantage of, for example, iCircuit is that the current flow can be visualized, which makes it very easy to understand the behavior of circuits and of individual components. Also, you can visualize the electric potential, which really helps you dig deep into the behavior of components in your circuits. And also MultiSim, which is the second software we took a look at, is very well suited for quickly and easily measuring quantities in a circuit such as current and voltage, and also sharing circuits online. And in the videos I make where I discuss various circuitry, I always create a MultiSim circuit which I share with you, which you can easily click on, and then it opens up in the MultiSim online environment. And lastly, TinkerCAD is a very easy to use software. It has a large database of components around the Arduino mostly and other microcontrollers, but also basic electronic components are available. And one of the more interesting points of TinkerCAD is that it really points out dangers in your circuit. For example, it tells you when there's too much current, for example, flowing through a light emitting diode. That's all for this video. If you have any questions, drop them in the comment section down below. Also, suggestions for future videos should go there. And that's all from me for now. I hope you have a nice day. See you next time here on The Fearless Engineer.